Hey, this time we're going to talk about formula writing and types of bonds. At the end of this lesson, you should be able to determine the formula of ionic and covalent compounds. Just a reminder that metals are found to the left of our black staircase here, and nonmetals are found to the right. Then metalloids are the ones that are found on the stair step. So properties of ionic compounds include that they have high melting and boiling points, indicates that they have a strong bond strength. Most are crystalline solids at room temperature. They're ions in regular geometric patterns, so they have a crystal lattice or structure. They're hard and brittle. They conduct electricity when molten or dissolved in water, so we call those electrolytes. An ionic compound is a compound that is made from a metal and a nonmetal. So remember, metals are located to the left of the stair-step line, and then also including the two separate rows at the bottom of the periodic table. And nonmetals are found on the right-hand side. Properties of covalent compounds are that the electrons are shared. There are no ions. So in ionic compounds, there are ions, and they actually swap electrons, okay? So with covalent compounds, they just share the electrons, and then we act as if those shared electrons count for both atoms, okay? They count as electrons. And only nonmetals are present, so it's two nonmetals that are bonded together. NH4 plus ammonium is an example of a polyatomic ion because it's made of more than one element. But it would, if it bonded with a metal, it would become an ionic compound. Okay, so other properties. They have low melting points, so they melt at lower temperatures, and also low boiling points. They're normally gases and liquids or solids at room temperature. They don't conduct electricity, and they normally don't dissolve in water. So our nonmetals are found to the right of the stair step. So when we write the formulas or write the names for ionic compounds, we always write the metal first, the nonmetals written last, and then we change the nonmetal to an IDE or IDE ending. So like our example would be sodium chloride, NaCl is the formula. The name, sodium, we named the metal, its elemental name, and then we change chlorine to chloride because it's the nonmetal. Here's an example problem. So what's the formula for sodium chloride? And I could give you these problems either way. I could give you the formula or give you the name and ask for the other. So what is the charge of and symbol of sodium? Sodium is a group 1 element, so it has one valence electron, and the charge would be +1. It's going to give away that one electron, so it can have a full octet. What's the charge and symbol for chlorine? Chlorine is a group 7 element, so it has 7 valence electrons. It wants one more electron to get to 8, so its charge is a 1- because it would gain an electron. So sodium gives away its one extra electron to chlorine, and chlorine accepts that one extra electron it wants from sodium. So we actually switch electrons. So when we write this out, sodium +1, chlorine -1, we switch the charges and then bring it down to a subscript to write the formula. So our example would be Na1Cl1 equals NaCl. We have equal subscripts, so we don't write them. We're not going to put a subscript of 1 on either the sodium or the chlorine. The formula for sodium chloride is NaCl. Sodium wants to give away 1 electron, and chlorine wants to gain 1 electron. So they're like perfect match. Okay, example problem number 2. I want you to try one now. What is the formula for lithium oxide? Pause the video and work this out on paper, and then come back, play the video, and check your answer. Okay, so make sure you pause the video, work the problem out. Okay, so you've gone through on your own and you have tried example problem number 2. Our question was, what's the formula for lithium oxide? Step 1 is, what's the charge of and symbol of lithium? Lithium is a group 1 element as well, so it has 1 valence electron. Charge is +1. What's the charge and symbol for oxygen? Oxygen is a group 6 element, so it has 6 valence electrons and its charge is 2-. So we write this down as Li1, O2. We're going to switch the charges and become subscripts. So our formula for lithium oxide is Li2O. Okay, so oxygen wants 2 electrons, so it has to bond with 2 lithium atoms because lithium only has 1 electron to give away. So formula writing for covalent compounds. Naming binary or 2-element covalent compounds is similar to naming simple ionic compounds. The first element in the formula is simply listed using the name of the element. The second element is named by taking the stem of the element name and adding the suffix IDE or "ide" like we did with our ionic compounds. A system of numerical prefixes is used to specify the number of atoms in a molecule. So 1 would be mono, 2 di, 3 tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay. So example problem number 3. What is the name for CCl4? Okay, so the name begins with the name of the first element, carbon. The second element, chlorine, becomes chloride. And we attach the correct numerical prefix, tetra, to indicate that the molecule contains 4 chlorine atoms. Putting them all together, that gives us the name carbon tetrachloride for this compound. So the name for CCl4 is carbon tetrachloride. Okay, example problem number 4, you're going to try naming a covalent compound. What's the formula for chlorine trifluoride? Pause the video now and work this out on your paper. Then we're going to check your work on the next slide. Okay, so example problem number 4, which you should have worked out on your own. What's the formula for chlorine trifluoride? The formula for chlorine trifluoride is ClF3. The name begins with the name of the first element, chlorine, so Cl. The second element, trifluoride, tells us there are 3 fluoride atoms. Putting these pieces together gives us the formula ClF3. ClF3, okay. Okay, so a note about polyatomic ions. A polyatomic ion is an ion composed of 2 or more atoms that have a charge as a group. Poly equals many. The ammonium ion, NH4+, consists of 1 nitrogen atom and 4 hydrogen atoms. Together, they comprise a single ion with a 1+ charge and a formula of NH4+. The carbonate ion, over here, consists of 1 carbon atom and 3 oxygen atoms and carries an overall charge of 2-. The formula for the carbonate ion is CO3, 2-. The atoms of a polyatomic ion are tightly bonded together, and so the entire ion behaves as a single unit. Non-metal atoms in polyatomic ions are joined by covalent bonds, but the ion as a whole participates in ionic bonding. So it acts as the non-metal, and then it could bond with a metal. Both ionic and covalent bonding are also found in calcium carbonate. So calcium carbonate, CaCO3, has ionic bonding between the calcium ion, Ca2+, and a polyatomic ion, CO3, 2-. But within the carbonate ion, the carbon and oxygen atoms are connected by covalent bonds. They are sharing electrons. And then here's a list of common polyatomic ions. You're going to want to start to learn these, at least a few of them that you're going to be seeing, and I recommend that you have a copy of this in your notebook. So example problem number 5. Is each compound formed from ionic bonds, covalent bonds, or both? So we have Na2O, that would be sodium oxide, Na3PO4, that would be sodium phosphate, N2O4 would be nitrous oxide, I believe. Okay, so Na is sodium, it's a metal. Oxygen is a nonmetal, therefore A would have ionic bonds. Sodium is a metal, PO4 is a polyatomic ion, so therefore it has both ionic and covalent bonds. N is a metal, O is a nonmetal, therefore covalent bonds. So that one would be nitrogen oxide. Is that right? Oh no. Nitrogen, dinitrogen pentaoxide. There we go. Okay. Example problem number 6. So you try 1 or 3. Go ahead, pause your video, work the problems out on paper, and then check your work. So is each compound formed from ionic compounds, covalent bonds, or both? Barium hydroxide, fluorine, and then potassium chloride. Okay, so you're coming back, you just worked through the problem and paused the video. So A, both ionic and covalent bonds because there's a polyatomic ion group. B is only covalent, and C is ionic, metal and nonmetal. Remember, covalent, 2 nonmetals. So in summary, the chemical formula of a simple covalent compound can be determined from its name, and the name of a simple covalent compound can be determined from its chemical formula. All right, thanks for watching. Good luck.